Welcome back. We're up to lesson 53. In this lesson, you're going to learn to write a linear equation using 2 points. Here are the 3 things that we're going to look for that demonstrate that you know how to write a linear equation from 2 points. Can you use a slope formula to find the slope? Can you do your substitution, your algebra work to figure out b? And can you finally write that equation in slope-intercept form? All right, this one's pretty cut and dry. It's a 1-sentence problem. Find the equation of a line that goes through the points 6, 8 and 1, -2. So we have the coordinate pair. So pretty much that's our goal, to create the equation that goes from that point to the other point. Here are facts. We have 2 points on a line, so we know we can figure out the rate from there, and we're going to use the rate of change formula to figure out the m in the equation. And so then here's the rest of our plan. We're going to use a rate of change formula to find the slope. We're going to substitute the slope and set up the coordinates in the equation. So in other words, I'm going to take either 6, 8 or 1, -2, and I'm going to plug that in for x and y into the equation with m. And then we're going to solve for the unknown. All right, let's put this plan into action. We're going to use our rate of change formula. y2 minus y1 over x2 minus x1 with these 2 points. 8 minus -2, here are y coordinates, and our x coordinates are 6 minus 1. So let's use this so we can identify the m in our equation. 8 plus 2 over 6 minus 1. All I did was distribute our negative sign, and we're getting 10 over 5, which means our slope is equal to 2. So we actually have our m in this case. All right, so now that we have m, let's find b. Y equals mx plus b. I'm going to use that m, and I'm going to choose one of the points to substitute. Okay, so let's use 6, 8. 8 is equal to 2 times 6 plus b. 8 is equal to 12 plus b. I'm going to subtract 12 on both sides. And in this case, I'm getting -4 is equal to b. Just to check, I'm going to use the other coordinate as well. All right, so -2 is equal to, our m is 2. Our x is 1 plus b. -2 is equal to 2 plus b. Subtract 2 on both sides. -4 is equal to b. So we actually have our confirmed b in this case, and we know m. So let's just substitute all of them in. Y is equal to 2x minus 4. That is our equation. All right, so let's finish just signing. So I'll find the equation of a line that goes through the 2 points. The equation y equals 2x minus 4 creates a line that goes through points 6, 8 and 1, -2. Done. Hit pause so you can jot this down in your notes. Again, this was a great plan. We were able to identify the m just using our rate of change formula, and once we had m, we can substitute coordinates to find b, and we verified it. Okay, for our second problem, we have a larger real-world road problem. So let's read it carefully. Miss Gibson made an initial deposit of $850 when opening a bank account. After the initial deposit, she deposited the same amount of money each month. The table shows the total amount of money A she deposited into the account after a certain number of months T since opening it. Write an equation in slope-intercept form that represents the situation in the table. Explain how to use your equation to determine the initial deposit and the amount of money saved each month. So what are they asking us to do? They want us to write an equation that represents the table in y equals mx plus b form, and then just explain how to use the equation. This is what we know. Right off the bat in the problem, first sentence, it tells us the initial deposit is $850, and we have data from the table. We're going to use that to find the rate of change using the rate of change formula and these two the coordinates. That way we can find y2 minus y1 over x2 minus x1. And that is how we're going to find m. Once we have m, we're going to write an equation. We've already identified our initial one-time fee as $850, so we already know the b in y equals mx plus b. This part is $850. What we have to figure out is the m. And the other little changes, instead of using an x, they want us to use t for months. So we're going to just put that in there. Okay, and they also want the amount deposited, the final amount, to be a. So fine. We'll still, instead of using y, we're just going to put an a here, where a is the amount and t is time. All right, let's actually find out what the m is going to be. The coordinates aren't, it's not going to change too much. We're still going to use our same formula, y2 minus y1 over x2 minus x1. And I'm going to just use these coordinates from our table. So 2350 minus 1600 over 10 minus 5. The top part, 2350 minus 1600, is 750 over 5. And we're going to simplify this. 750 divided by 5. You can take out your calculators if you'd like. And I actually recognize I'm rushing a little bit, so I believe it's 150. Let's double check. I don't want to make a silly mistake. It happens, but I want to see if I can prevent it. 5 goes 25 5 times. Yep, 150. Okay, so now we've identified what our m is, our slope. M is equal to 150. So let's put all those different parts together into our equation. A is equal to 150t plus 850. This is our equation. So we've done the first part. We represented the equation. Now we have to explain how to use the equation. Okay. To find the total amount, A, use the equation. A is equal to 150t plus 850, where t is the number of months. For example, for 10 months, multiply 150 by 10, and then add the initial deposit, 850. The total is 2,350, period. So at least I explained how to use our equation. We're just going to substitute it for 10 months, multiply 150 by 10, and then add the initial deposit, 850. So I tried to make it very basic so that anyone could see how we wrote it in. But that's it for today's model. Math Marvels, again, we're just using what we know, which is figuring out change of y over change of x when we want to know our slope, our m. And in our problem, we were able to identify what the initial deposit was, our one-time fee, our B, as 850. Using that, we can make an equation and find any other number in this context. We'll see you in the next lesson.